All right, welcome back. This is another episode. I realized from looking at the previous ones that you can't read the Excel spreadsheet on my screen. So maybe you can now. I improved the size. So I took our flow diagram from over here on our Visio and moved it into our transition. So each condition here is represented in our transition. And you can see that we have several steps that could go to different ones um, from either one here. So like 10 can go to three different spots, 15 to 2, 20, 25, 30, 35 can only go to one. So the way we look at it here is if we want an and system, as in these both need to be completed in order to move to the next step, we do them in series. And if they are an or statement where it can go to different steps or perhaps even the same step but different reasons to go there, we have an or statement. So the way the and works is you need yes and a yes here, while an or statement works with just a one yes, we move to the next step. And if we're not there, we can check the other conditions. So with this, we can receive and send product with our skim tank by getting ourselves all the way to step 25. We go through there, and when we receive the production end flag, we're going to go through where we can't get the product send and the product call flag, and then we're going to pump down and go to the end. There's a few ways you could do it. You could do it from different steps. It kind of depends on how you want to do it. And this is meant to be human readable, something that you can look at and uh, understand the flow of the process. So try to keep it neat. We have a lot of our feedback loops here that can be done. Look at it the way that you like and try to come up with the best solution that you can. Once we've done that, we've transferred everything over here to our different steps, our step descriptions here, and then we have our transition description. So this is what's going to show on the screen on your HMI as your transition description. So basically what it's looking for if it's going to move to a different step. We have our parameters here, which are mainly flags, and then what value you're looking for in there. So if you use a analog, like if we wanted to do this as an LT SV0607, I think it was, and then we could do that as 5%. That would be our set point. But I'm not going to do it that way. The level transmitter is just mainly going to be the indication. So sometimes you need a max time override for possibility of instrument failure, or maybe you want to look at two different instruments. If you want to look at two different instruments and transition on either or of those, that would be an or statement here. You would need another line. Or if you wanted to do both of them, you would need an and statement as well. So the max time is there to override the step transition if we're waiting for that. Another thing you could do is alarm it. If that alarm is part of an interlock, then we can shut it down on that. A lot of different options for that. And then finally, we have our transition steps here as to where we transition to. So this is going to indicate what our steps are doing and where we're going to transition to. So this will correlate to the code and your sequencing in the future. So next, what we're going to look at is setting up our activations. So this is where it gets a little bit complicated. And basically, we're going to try to transition and use our transitions to create all of our steps, and then each of our steps are going to have specific activations. So this is set up to fill in properly. So we can just go 0, 5. Oh, I guess we're going to need to delete this row. There we go. Then we have 10, 15, 20, 25, 30, and 35 are all of our steps. And then we have our columns here, which are just basically going to be our outputs. So we have all of our outputs here, and then whether they're controlled or not. If they're controlled, they're going to be controlled by a PID, and we will address those later. So we'll just leave those out for right now. But we will take this group here. You can either type them all out, or what I do is just transpose it. And transposing gets a little bit weird, but just massage the data the best you can. So when we're going to move that over to, we're going to put the values, and then we have all of our values filled in. Back to our outputs. We don't need this anymore. And then we have our agitator, and then our agitator speed. We're going to leave this one out. We could set different speeds inside the activation, but I have a feeling that this is just going to run at a set speed, but it's something we can add later. And then this pump speed is going to be controlled by a PID, and this CV is going to be controlled by a PID. So let's look at how those are made. So this pump speed is going to be set, controlled by a PID, and a PID is actually a pressure loop, but we're going to call it, for the sake of just completing this all internally, we're going to use the flow. So we're going to call it a flow speed loop. So we're going to create a new PID here, and we're going to use the input, this flow, so the flow from the density meter. And then it is flow from the density meter, and it's a controller. So it's FIC, and then SP0149 for the instrument that we're controlling the flow for. So this is going to be product send flow controller. And then we have our PV, which is our input, which is FT SP0149, and our CV, which is our output, and that is going to be PSP0140, and the analog out of that. And we're going to enable this. Oops. Using an enable flag. And an enable flag is going to enable another part of the code based on some sort of logic. So this is going to be the PID logic, and we're going to enable it using that flag there. So we can put that in our activations. And if we look at it, we can see it there. Keep the formatting the same. And we can see that we don't have a fill in here. So that is because we created our PID, but we haven't created our enable yet. So we will create our enable. So this is our tag. We're going to product send flow controller enable. So we can just use copy paste. And then it is a PID enable type. And any conditions to run this, if you had an interlock or something like that, we are going to use an interlock of pump is okay to run. So not pump fault. And that's going to be our condition to run this PID. And then now if we look over at our activations, we can see that there. So those are the activations that we're going to use. There's more, but we'll just make it simple. So we're going to delete the remainder of these columns. Get rid of this code up here. Now we're going to go through and activate our activations here. So